Hi everybody, welcome to section 9.2. I wanted to do a video first on just how we can verify that this is true, that the distance from the focus to the point is the same as the distance from the point to the directrix. So I did hope you took some time to look at these pictures and play with this distance on your own. Were you able to see what this was saying? And if not, we'll just go over it now. So a parabola is the collection of all points P in a plane that are the same distance d from a fixed point F as they are from a fixed line D. The point F is called the focus of the parabola, and the line D is its directrix. As a result, the parabola is the set of points P for which the distance from the focus to the point is the same as the distance from the point to the directrix. So when we look at that, it doesn't really matter which curve we pick, how it's oriented, it won't matter. So if we pick this point here, the definition is stating that the distance from the focus to the point is the same as the distance from the point to the directrix. And so it doesn't matter where that point is on the curve. If your point was up here, this distance from the focus to the point would still be the same as the distance from the point to the directrix. And so if we wanted to show this, we would want to give these points some ordered pairs. So the ordered pair for the focus is a, 0, and in this case, since the parabola is oriented on the x-axis, the equation of the directrix is x equals -a. So what we know from these pictures, and hopefully and kind of reading down here as well, is that the distance from the focus to the vertex is the same distance from the vertex to your equation of the line of the directrix. So if the focus is a, 0, the directrix is going to be x equals -a. Over here, your focus would be 0, a, and your equation for the directrix would be y equals -a. Alright, so if we're playing with the distances, we still want to find the ordered pair for these. The point on the parabola would just be x, y, and since we know that the directrix is the equation x equals -a, when you look at the distance from the point to the directrix, it's going to be the absolute value of x minus -a, or the absolute value of x plus a. So let's go to another page and prove that the distance from the focus to the point is the same as the distance from the point to the directrix. And so when we look at this, we're going to have so then we're saying that the distance from the focus to the point and the distance from the point to the directrix, so we'll have the square root of x minus a squared plus the y minus 0 squared. And then this is going to equal the absolute value of x plus a. And what we're going to want to do is just bust out some of our algebra skills and see and hope to get to the point where we get y squared equals 4ax. So we can start by squaring both sides. We'd end up with x minus a squared plus y squared equaling the x plus a, the quantity x plus a squared. So when you square the absolute value, you can almost think about these absolute values as if they were parentheses. Do the inside and then square it, so we don't need to keep the absolute value anymore. when we expand this, we'll have x squared minus 2ax plus a squared plus y squared, and then equals x squared plus 2ax plus a squared. And when we want to put everything on, well, we're trying to get to y squared equals 4ax. We have our y squared here. Let's bring everything else to the left side, to the right side. So we'll see that the x squareds cancel, and then add 2ax to both sides, which is going to give us y squared equals 4ax, and then we would want to subtract a squared to both sides. That's going to make this a squareds cancel, and now we've come up with that equation of the parabola. So I hope you found this helpful. I'll see you in some videos to go over some examples.